So we're here to talk about Agile for hardware. Vishal and I are both, very passionate about this topic because we've definitely seen hardware teams get the benefits of Agile. It's just how you approach it is the challenge, and we definitely see more predictability, higher value, faster. So we want to share with you how that happens. I'm Dorian on the left. I'm the founder, leader of the MAHD framework, lead consultant, and I used to be an electrical engineer, went into engineering leadership, then moved into product management leadership, executive leadership, consulting, and I've seen the problem, all around the horn of product development. And we'll start out by what's the problem we're trying to solve a little bit. With me is Vishal. He's one of our MAD partners and lead consultants. Do you want to say hi, Vishal, since
Hey
we can do
everyone,
that?
good to have you all. Thanks for joining. Yep, I kind of came through a little bit of a different background. I was an engineer and software engineer myself initially. Moved into project management, ran a few PMOs for a few of the companies that are listed there. And I kind of, got excited about the whole big picture thing, organizational flow state and such. And especially with Thermo Fisher, I kind of got a lot more into the hardware side of Agile, and I kind of had a lot of good ideas come through organically. But then, once I ran into Dorian, it all kind of made sense. So we've been working together for a while now.
Yeah. Yeah, in a lot of ways, we often frame Agile for hardware and really any good product development process is just structured common sense. But trying to do that with a herd of people, different skills, different background, what seems like might be common sense is difficult. But that's how we kind of like to view it. We'll start off today a little bit with what was our vision, what are the benefits that we see. Vishal is going to take us through the MAD framework a little bit, some key elements as much as we can go through in our short time. And we'd like to share a couple of case studies with you just to see how different companies applied MAD and some of the benefits they saw, and then open it up to Q&A. But let's look at Q&A throughout. If we're losing you at all, let's pause and take questions, and we might even take a pause between sections and see what questions. That's probably a good approach. So let's dive in. Um, so a lot of you said you're not familiar with Agile for hardware, but how many of you have a hardware background? Can you share in chat, or just, how many of you have hardware in your background at all? Like you've worked on hardware projects. Anybody? I'm just bringing up chat here. Some hardware, great, Reggie. Kelly. Okay. For 2 seconds. Okay, I love it. All right. Well, if you haven't been involved in hardware, then what we're going to talk about the problem may not make as much sense. But so we've been involved with traditional stage gate, and even if you're not in hardware, you might be familiar with traditional stage gate. It's, there's early stages of it, discovery, definition. And I used to do this as a product manager. I used to receive be the brunt of this as an engineering manager. And the front end is a big part of the problem because we're basing we're creating a lot of assumptions. The core document is a requirements document. It's kind of based on a lot of assumptions that kind of ripple through the development process, and the negotiation between marketing, which is often product management, and R&D takes a long time because they want to get it right. They want to be able to commit to a project. They want to say this is what we're going to get at the end. Then they agree on the schedule, and it becomes really a contract. And when you have a contract based on assumptions, we know it just doesn't work very well. And then the results are often that the learning is coming too late, and you're having to do a lot of difficult decisions near the end of a project. And often those decisions end up being a late to market kind of situation or reducing scope that you thought was valuable. And stage gate or waterfall was never really meant to be a good way of working. It wasn't meant to drive innovation. It was really meant as a governance framework. Is the team, did they do everything they needed to do to hit this milestone, hit this gate? Check, check, check. Let's have a big management meeting. Let the team go away for a long time, come back and check it again. So it really wasn't designed as a great collaborative tool. It was great for governance. Agile came out and kind of helped solve that. And we know if you work in software and follow traditional processes. It was extremely painful because you would write these, detailed requirements, documents, use cases before you ever started coding. And you knew that if I just coded and tested and adapted, that I was going to get a better outcome. So software teams absolutely needed a better way. And of course, you're all familiar with the Agile Manifesto and the principles. So we don't need to go too far into that. And it works. It works for software. The time boxing, delivering in short cycles, allows you to be more adaptive. Collaborative is kind of built in because you're doing stand-ups and you're doing preparation for sprints and you're estimating together, doing a lot of collaborative activities. And you can just incrementally create value. You're adding through user stories, new features, and building. And you can do that because there's a lot of scope flexibility and things like minimum viable products. The challenge that we see and which started us on this journey of does it work for hardware? Can we modify it to do a better job is because we know that the tactics were really designed for software. You have a continuous flow of releases. There really isn't a lot of cost to change. We can do this plan, build, test cycle almost daily to add features and validate. And often the teams themselves look differently, where software teams kind of have shared skills and there's a lot of overlap in your ability to do things. So Agile shifts. The nice thing about Agile is it really shifted the conversation. Where StageGate was about governance and we would hear from executives all the time, if we just get more accurate requirements up front, all of our problems would go away. And what they're really doing is asking the wrong question because they're asking a governance question. What we should be asking is more of how can the teams work better together? How can they collaborate to solve the problems that are going to be inherent in product development? So Agile shifts that conversation, which is great for us because it allows us to have a better conversation with executives. When I was in consulting, I will still am, but I used to do more traditional StageGate, and we would try to fix StageGate and turn it into more of a way of working. And that was a difficult conversation. Agile allowed you to have a better conversation. So it's really one of the nice things about Agile is that it allowed a new way to talk about product development. So if you've ever been involved in hardware, you know hardware literally is just different. Everything about it is different. Yeah, we're delivering a solution at the end, but that's about the only thing that's similar. The business model is different. The constraints that the teams have to manage are very different. We've got a lot more cost considerations. We have very hard specifications. We got more time constraints. We have cross-discipline resources. We got electrical, mechanical, software, all working together. Schedules are critical. And the big thing really comes down to decisions, how decisions are made. In software, really the big decision is which feature should we do next and how do we validate that? For hardware, it's about what's the right trade-off. Should we balance this cost with this scope, with this schedule? Is it this feature or that feature, this level of specification? Can we live with that specification? And at the end of the day, the teams have to live with them because you're going to launch it and it's very difficult to change. So there's no real iterative development once it's in the field, unless it's a software or firmware upgrade. And because those decisions have such an impact on the market success, these decisions often are second guessed or even made by executives. So executives are always in the loop. They're always huddling over hardware teams looking at decisions because every decision they make has an impact on the market success or not success. So agile tactics, expecting them to work for hardware really never made sense, but people try to do it. So we really want to take a different approach and modify it. We want to maintain the principles, but really adapt the tactics. So just to summarize, if you're not familiar with hardware versus software, software is about incremental value, and it's about that what's next. Let's just keep building on it. And you don't have to even make a decision often of should we develop this platform or not. You've already made that decision. You're just building on it. Hardware is a lot of discrete decisions. Should we build this product or not? Should we build this product or that product? And it's often managed as a product portfolio. And then it comes all down to trade-offs. And ideally, we have a process that can manage both sides. We want something that can manage software and hardware. But the challenge for software, I'm sorry, Agile generally, is that the value of software tactics goes down as you have more discrete products and projects. And so we want to resolve that. So just to kind of summarize, and we kept always try to, how can we explain this more clearly? And I don't know if you've seen this video from Steve Jobs, but we want to share this, and I hope the audio works because I might have to stop and restart this for a second. But Steve Jobs did a really good job explaining what are we talking about at all. So let's see what he has to say, and then we'll come back to it. It's about a 3-minute video. So let's see if this audio works. I just paused it. Does the audio work okay, team?
It doesn't.
We didn't hear anything.
No.
Yeah. Okay, so I'm going to stop sharing here, and I have to reshare because I forgot that when I share, I have to make sure that I'm sharing my sound.
Little checkbox over there, right?
Yeah.
There's a lot.
Yeah. Yeah. Okay, I'm going to restart it.
What's important to you in the development of a product?
Good. Oh, it froze for some reason.
Actually, he's thinking. Or did it freeze?
It did
Yeah,
freeze.
it did. Because he does pause for a long time.
You know, one of the things that really hurt Apple was after I left, John Scully got a very serious disease. And that disease, I've seen other people get it too. It's the disease of thinking that a really great idea is 90% of the work. And that if you just tell all these other people, you know, here's this great idea, then of course they can go off and make it happen. And the problem with that is that there's just a tremendous amount of craftsmanship in between a great idea and a great product. And as you evolve that great idea, it changes and grows. It never comes out like it starts because you learn a lot more as you get into the subtleties of it. And you also find there's tremendous trade-offs that you have to make. I mean, you know, there are just certain things you can't make electrons do. There are certain things you can't make plastic do or glass do. And as you get into, or factories do, or robots do. And as you get into all these things, designing a product is keeping 5,000 things in your brain, these concepts, and fitting them all together in kind of continuing to push to fit them together in new and different ways to get what you want. And every day you discover something new that is a new problem or a new opportunity to fit these things together a little differently. And it's that process that is the magic. And so we had a lot of great ideas when we started, but what I've always felt that a team of people doing something they really believe in is like when I was a young kid, there was a widowed man that lived up the street, and he was in his 80s. I think he might have paid me to mow his lawn or something. And one day he said, "Come on into my garage, I want to show you something." And he pulled out this dusty old rock tumbler. And it was a motor and a coffee can and a little, you know, band between them. And he said, "Come on with me." We went out to the back and we got just some rocks, some regular old ugly rocks. And we put them in the can with a little bit of liquid and a little bit of grit powder. And we closed the can up, and he turned this motor on. He said, "Come back tomorrow." And his can was making a racket as the stones went around. And I came back the next day, and we opened the can, and we took out these amazingly beautiful polished rocks. The same common stones that had gone in through rubbing against each other like this, creating a little bit of friction, creating a little bit of noise, had come out these beautiful polished rocks. And that's always been, in my mind, my metaphor for a team working really hard on something they're passionate about, is that it's through the team, through that group of incredibly talented people, bumping up against each other, having arguments, having fights sometimes, making some noise. And working together, they polish each other. And they polish the ideas. And what comes out are these really beautiful stones. Yeah.
So that was an interview from 1995 with PBS. So Steve is always a visionary, of course, and he had an agile mindset really much before agile was even a thing. I love how he refers to, and he doesn't call it, PRDs.
What's important to you in the development?
He doesn't call, he didn't really call out PRDs, but he's talking about the disease. And we see that all the time where if we just have this perfect document, this perfect idea of what we're trying to build, that the team's going to magically create it. And it doesn't work that way. So, he talks about passionate teams. How do you learn and adapt and those trade-offs? And that's really what Agile for Hardware is about those trade-offs and the craftsmanship and the process. We were excited when one of our customers called that video to our attention. They said, we'd like to share this video with our company and explain that that's why we're doing the MAHD framework, because this is what the MAHD framework enables us to do. And we're like, of course you can do that. We were just excited that they built that connection. And that's how we view it as well. That the framework is just letting teams do their best to polish these rough ideas into something amazing. And how do you do that? So the Modified Agile for Hardware Development Framework is an Agile-based market success framework designed to optimize the team's way of working while meeting the needs of physical solutions. So it's based on Agile principles, but a lot of the tactics and methods you're going to see are different. And one of the key distinctions is the market success. So a lot of teams attempt Agile by treating it as a development process, and they'll still write the PRD. They'll try to get agreement, alignment on that, and then they'll break it down into time boxing and let the development team kind of execute in, more 2-week, 4-week sprints and think, oh, we're agile. But you're really getting a fraction of the value, because the whole value is the trade-off decisions. It's that polishing. It's that exploring quickly, learning and adapting quickly, collaborating, and how do you do that in a structured environment that keeps it moving at the right pace, the right velocity. And that's the magic, and that involves market trade-off decisions. So it's got to be a market success framework if you're going to get the benefit. Or more simply, we like to call it a process to transform great ideas into great products. So we want to, in the MAHD framework, want to make sure that we're building in Agile principles and getting that way of working. We don't want to lose that. We want to have teams really be able to focus on value, how to collaborate, the transparency, managing risk. All those are huge benefits. We don't want to lose that, but we also need to bring in some of the governance. And we need to do it in a way that works with iterative development, makes management happy that the schedule is understood and you know how to manage to a schedule. So we don't want to lose some of the elements of Waterfall, but we're going to blend this together into a framework. And we can't also lose some of the other things that we're going to have to either integrate with or align with. Some teams are very heavy into SAFe, Scaled Agile, or heavy into Lean and Six Sigma. And so we want to make sure that whatever we're doing aligns with that. So teams aren't, completely restructuring and coming up with a completely new framework. And things like design thinking, we don't want to lose, because those have huge value to hardware as well. So we want something that really is a framework that can work in almost any environment. Our journey, we started before 2017. We saw the problem. My first consulting engagement was with a company I was consulting with. They brought in Agile. The software team was off and running, no problem. The hardware team was struggling, and it struggled from the very beginning. And we started analyzing that, tearing it apart and saying, okay, what would it look like? And that was kind of the trigger for the MAHD framework. We've been evolving it since. This year, we're going to launch MAHD 4.0. And you'll see some of the evolution, 2.0, 3.0 as we work through. And a lot of companies along the way we've trialed with, have been experimenting, and have been deploying. Our first customer with the official framework was Lego. And so Reggie, we saw your Legos and said, hey, that was really our first official customer for the MAHD framework. So it's evolved quite a bit since then, but Yes, and they weren't using it just for their bricks. They have electronics, they have robotics, other solutions that they were looking for a framework for. So that's how they approach MAD. So the complete MAD framework, we won't have much time to talk about today. We're going to focus more on the core. The core is about project excellence. So we're assuming that you're initiating a project. It can be as small as 2 people to get initiated. And how do you do that? And Vishal is going to walk us through the details. If as teams mature, as organizations mature, we have to think beyond the project. We think about portfolio management. We think about innovation pipeline, sustaining engineering. So we really want an agile approach throughout the whole product life cycle. So that's what the complete MAD framework covers, and that was a launch as 2.0 as we expanded it. So some of the outcomes we typically see, definitely the first things people see is improved team satisfaction. But ultimately, companies are looking for speed, increased value, and generally teams get about 25%. We've seen as high as 50% higher speed. Depends on how you calculate it, what your starting point is, et cetera. And you'll see where a lot of that benefit is coming from. And a lot of that benefit's coming from the front end, where there's just a lot of waste that can be optimized. Okay, so that was my introduction. I know it might have been long for an introduction, but let's dive into the details. What are we talking about? But I would like to, as Vishal warms up here, see if there's 1 or 2 questions in chat that we can address, if there is any, from just what I shared. Or you can open up your mic, small group.
Yeah,
Looks
I
like there's
just got a quick question, Dorian.
yeah. Yeah.
So you mentioned Six Sigma, and I work with hardware companies, well, hardware and software, so there's an interface there. But they were in the past they've tried to use Six Sigma to kind of introduce an agile type framework, but it's all focused on governance. You mentioned it earlier on. I guess we'll learn a bit in a second, but in terms of differentiating Six Sigma to what you guys are describing here with MAD, can you give us a brief summary of that?
Yeah, I'll give you a summary. It depends because every company implements Six Sigma a little bit differently based on their needs. Some much more focused on manufacturing, some take it all the way left. So a good example is one of the tools that we brought into the MAD framework. We call it the focus matrix. If you're familiar with total quality management, which is kind of loosely aligned with Six Sigma, they use the house of quality. Which blends customer needs and attributes and tries to build that relationship. We found that extremely valuable, but it's usually way too much detail for teams to adopt and use. It's time consuming. You need a lot of data, but we can get the benefits of that. So in a sense, we're blending some of the concepts a little bit. And the MAD framework truly is a framework. It's how, as a team should think, it's how to think about whether it's that next iteration that they should work together towards. And then it's as many of the tactics and methods as they want to use, but you can also then blend it with Six Sigma pretty seamlessly because they're not incompatible in any way. It's just how the team wants to bring them together a little bit. And that's true of stage gate, that's true of SAFe, in any other process. That once you have the big picture framework and how the teams kind of think about the project, thinking about iterative learning and execution, then bringing in the other processes are very straightforward, if that makes sense. And we'll go through that and see if it helps at all.
Thank you. Yeah, it does.
Okay. All right, Vishal, you want to kick us off? And I'm sure this will raise some other questions.
All righty, if you all can hear me. All right, so basically, thanks, Dorian, for the introductions. So core MAD, as he mentioned, right? We're going to focus on that for today. That's kind of like at the team level. It focuses on more at the project level excellence. So a MAD project, the good thing is that it can literally be started with a very small core team, maybe a couple people. You don't even need the whole team to start off. And a cross-functional team, typically if you have lots of different technical areas disciplined involved, they can literally kick off a project between 1 to 3 weeks. And even for a brand new innovation project, the way MAD is structured and some of the ideas and tactics and things, it allows, and imagine that in hardware, right? being able to kick off a project very, very quickly with just the right set of people initially. So if you could click, please. So basically, MAHD, the good thing about MAHD is that it is applicable to any size project. Dorian, can you click, please? Or I'm not stuck. Hang on, sorry.
Oh, you're not seeing it?
Oh, sorry. My computer was a little slow here. All right. So anyway, the good thing is that it is applicable to any size project. And so basically, the agile principles will allow teams to kind of that we built in will allow teams to reduce the risk, align the teams, drive fast decisions, and the number one agile principle of inspect and adapt. The USP is that it was purpose built for hardware. Obviously, that can include firmware and software, but there's specific challenges around holistic schedules or integrated solutions across multidisciplinary teams. Constraints, product costs could be a constraint, timing, certifications, third-party dependencies, lead time, shared resources, it just goes on and on. So there's so many different things that have to fall into place, like Steve Jobs was mentioning, before things can actually work in a good hardware product. All right, next slide, please. So there are some key modifications that are required. So the first one, and again, these are all built on principles. So as we go along, we'll talk about some of the principles involved. The first one is an empowered agile team with cross-functional skills. So it's willing to engage in some healthy friction, kind of rub against each other, but in a positive way. But the idea is to harness their collective wisdom. And that from any agile perspective or any team success perspective, that's kind of table stakes. So the coaching that we provide and obviously other coaches provide is one of the key things that is, it's kind of a qualitative aspect of it. The second big thing is the on-ramp, or basically what we call as the MAHD on-ramp. Typically with hardware, some advanced planning is required. You can't just, it's not in software, you can get a bunch of user stories and get going, work on some features. With hardware, you need to kind of think about things in a bigger picture perspective. But the idea is that instead of going into stage gates and things, we're going to use certain tactics to identify the key areas to focus on. So that the team can rapidly initiate the project and start moving in the right direction. We fondly call it the big rocks first. And that's the principle behind that. And the third thing is how the team is gonna think, execute, learn, all the while making quick trade-off decisions throughout the process to be able to move fast. A lot of wait time is typically involved in decisioning. And the last thing is how do you manage the cross-functional backlog? There's going to be a lot of moving parts, obviously. And so how do you kind of keep all of that aligned at the big picture level? All right, so the on-ramp, as we talked about, I think this is I don't know if anyone on the call has a Super Mario experience, but there's the rocket boost that you can use at the start of the race. So we think about the MAHD on-ramp as kind of like that. With software, you can just write a few user stories, get some features going, and teams can literally kick off and start delivering in 2 weeks. Can't necessarily do that with hardware. So that's where the idea of the vision brief comes into play. So we have something called a vision brief, which is like a strategic intent for the project. Who's the target customer, the market positioning, what are some of the constraints? The next thing is what we call as user stories, and we'll talk about how they're different. But essentially, they define what the customer wants to achieve and why. The product attributes typically outline the skeleton of the solution, so the team starts thinking about those. The focus matrix starts bringing all of that together. The big, again, as we mentioned, the big rocks, but the idea is to gain a common understanding of the biggest areas of risk and innovation. So then the team kind of gets into what we call as the IPAC iteration plan, which is essentially a directional plan, which includes some preliminary prototyping ideas and essentially what the iterations are going to look like. And then as a final step, the team will basically build a iteration backlog so that they can start executing against that. So, as I mentioned, user stories in software are relatively straightforward as a so and so forth, and you can literally have certain team members go off and build it. In hardware, we can't necessarily do that. For example, this is one of the real examples that there was a company that was trying to build an automated forklift or a smart forklift. From their perspective, what we call as a user story is essentially something along these lines, which is, hey, as a forklift operator, I want to be quickly able to pick up my cargo so that I can move inventory fast. That's essentially a user problem, and that's what we need to solve. So the nature of hardware is such that you need, we focus more on the user need, and then the team's going to figure out how to solve that in the optimal way. And again, so user needs are typically described at a much higher level, and they're meant to capture what the user actually wants to do with the solution, or what are their problems. There's this is, and we sort of touched upon this earlier, but in the traditional way, we go through the entire negotiating process, and there's a bunch of back and forth, and limited collaboration, more of a contract negotiation, which is where Agile kind of found its initial groove. The MAHD approach is essentially about setting up the problem to solve. And then collaborating as a problem to figure out what's the best way to solve this, addressing the big rocks first. So what we found is typically in the same time that a traditional team works through the PRD, specifications, architectural documents, and essentially builds a Gantt chart, MAD teams would have actually worked through a lot of the major areas of risk and innovation, built some early prototypes, even solicited customer feedback, and would have started making some early trade-offs. So the result is that now you have a significant amount of risk reduction and a much more predictable schedule, because again, you've kind of optimized on how you go about it, and you prioritize the right work first. So then you have a better, clear understanding of where you are, where you need to focus on, and how do you drive the solution forward. The second area that is, it's kind of the big area of change. And again, people are used to iterative development these days, but with hardware, it means something slightly different. Yes, we do want to have iterations to use the Agile ideas and concepts, but hardware cannot be developed in little pieces, right? So it has to have a holistic insight or view that we need to think about. So what we call as the IPAC iterations are essentially, it follows an acronym. Typically what we when we coach or train, we talk about P first. So P is what is the right level of prototype we need for us to learn as a team. I stands for what do we need to integrate across different functions. A is essentially what do we need to align, how and who, and so on and so forth. What teams, executives, external party suppliers, and all of those. And then C is essentially, hey, how are we going to validate this with ideally, as much as possible, customer feedback. So now that you kind of start with the hypothesis, you build something as a potential solution that might make sense, and then you kind of iteratively work through without actually building the final version of things. The system level integration goal, like essentially every iteration, you have a system level iteration goal that will drive the focus of each iteration, incrementally building and validating the solution via prototyping, and then you kind of keep getting the customer feedback. And then as you get the feedback, you validate and you make optimal solutions throughout. So the good thing about the way this is structured is that the IPAC iterations can be shorter or longer, depending on what you're trying to learn and what are some of the alignment milestones you're trying to hit. So within the IPAC iterations, the shorter iterations are essentially the 2-week sprints, which will allow the various subsystems or the swim lanes or disciplines, and there's different ways to structure this, but basically for them to work in smaller teams, focus on the execution, focus on the tasks that they need to deliver. So as we talked about, there are the second, sorry. So now we're going to talk a little bit about the MAD prototypes. a key consideration is that iteratively developing the solution is essentially how we're going to develop the prototypes. How are we going to evolve the prototype? And one of the big differences is with prototype, what we mean is that any demonstrable output for the purpose of learning. So it can be anything from a diagram on a sheet of paper to a 3D printed little part of a solution, or even a partially working solution. So as the project evolves, the various prototypes gain functionality and fidelity, so that satisfies the learning objective essentially. So a related item to the concept of of an evolving prototype is a vertical slice. How the main thing that every team will start off with every iteration all the time, what they're asking is, hey, what do we need to learn next? And so this is often part of the on-ramp. There'll be some questions about, hey, what do we need to learn now? But it changes as the project evolves. And a vertical slice is essentially a portion of the system that starts coming together to learn something, to validate a technology potentially, or to validate a hypothesis in front of customers. So if you need to, for example, if you want to validate, whether you have the right interface or how the interface might function, you don't have to build the whole thing, but you could have potentially a partially working PCB with some early firmware and software, but no chassis. And then you start putting that together and you see how that works and you try to get some feedback on that. And that could become an iteration goal. So MAHD Agile is not about a serial development of features, but essentially how the features combine and integrate to satisfy the needs of the user or what's important to the user essentially. So I think this is what I'm going to do next is I've talked a lot about different principles and things and little pieces that how they all kind of help. What I'm going to do next is try to demonstrate an entire end-to-end sort of thing. So what might progress look like? So typically a MAHD project will go like this, right? You have the strategic intent, which is the vision brief. Then you have the on-ramp. Once the team does the on-ramp, then they basically go into rapid, what we call as divergence convergence cycles to start mitigating the areas of biggest risk and innovation. So you'll see that there's a lot more investigations initially, and then as they continue to work through it, as the big questions get answered, more becomes known, and they can start locking things down. And they might continue to do additional divergence convergence cycles if they weren't able to satisfy a certain unknown, or if there's new unknowns that they've uncovered, and that's okay. But the idea is to continue to kind of work through the big rocks and continue to and start deciding the things, right? Making those trade-off decisions along the way. And where it's difficult, you might actually have something what we call as a strategic flexibility. And so the idea is you have a particular part of the system that is extremely critical, that adds a lot of value, and you think you can squeeze some more value there, you might actually strategically keep that part of the architecture or decision open while you lock down everything else so you can get to a design freeze. There's various ways to slice and dice it. We leave a lot of stuff to the team's discretion as well, because we want them to be empowered. Again, a lot of Agile principles baked into the entire framework, and we do want teams to kind of, obviously have a quick way to get started, but also to learn as they go and see if they, if something else might make change in their specific situation. So again, the way this progresses is, address the high risk, high value items first, demonstrate and validate the progress that you're making through prototypes and vertical slices, then continue to refine and adjust the plan based on the learnings and trade-offs. So the last area, I think quickly that I'll go through, this is actually one of the easiest ones. Most teams don't have any challenges because they're used to backlogs. But the big thing to call out over here is that, instead of one single stream backlog with a bunch of user stories, with MAHD, you're going to have a higher level IPAC goal. So you're going to have some user stories and epics that might be more at the IPAC level or the iteration level, at the system level. And then you have a breakdown across different swim lanes to satisfy some of those goals. Obviously, that does not mean that everybody is just focused on just the top level stuff at the system level. Every swim lane potentially or subsystem might have their own additional things as well. And so obviously there's a balance and there's a way to kind of move forward. But at the end of the day, the system level is a very important focus for every swim lane. The swim lane, just from roles perspective, typically you would have a technical leader that drives the swim lane. We do have some changes in some of the roles that we recommend. But net, I think one of the things that is critical with the way MAD is structured it basically comes down to the risk profile. With stage gate, you kind of start off okay. You kind of think that you have a plan, and so the risk is being mitigated or low. But there's a ton of assumptions that are actually baked in, and so as actual work starts happening, assumptions start to fail. Project delays, changing requirements, priorities are not as clear, especially in PRDs and things. So what starts happening is the risk accumulates towards the end. Harder decisions need to be made. With MAD, we basically want to do the reverse, where we want to kind of look at all the big risk areas first, or even the big areas of opportunity, and then continue to kind of knock those out of the way, so that thereafter it becomes much more predictable. So the irony that we've always seen is that the schedule predictability is actually higher with a MAD project than with a traditional project. So as the variability goes down, you continue to have better outcomes. So I'm going to hand it over to Dorian. Again, we'll pause for a couple seconds. I think Dorian might have been answering some things on chat, but if anyone has any immediate quick questions that they must ask right now, we can obviously stop for it. Otherwise, Dorian can talk about a few use cases.
Yeah, and sorry, I screwed you up, Vishal, because I was trying to answer in chat, and I'm supposed to be clicking for Vishal's. So it doesn't always work. And that's an interesting challenge of context switching that hardware teams have, is how do I manage multiple projects? Resource sharing is something that we always have to address. I liked in chat, just to trigger any thoughts, is Reggie's saying thought leaders have gone away from points and burn up charts because they don't see a lot of value there. And we've seen the same thing. So when we think about progress, when teams think about Agile for Hardware, they kind of want to jump to points and, we're going to get so much more predictability because we can do burn up, burn down on tasks, etc. It doesn't really work that way, not for hardware, really at all. Because the real value that teams get and how they get that predictability is knocking down that risk and then understanding the project. And once they really understand how to execute what they need to execute, they're very good about estimation. They're very good about hitting a schedule. And one of the key advantages is that if you have a constraint, which a lot of teams do on a schedule date, like we need to hit July 15th to hit Christmas. That is a constraint, that's a problem for the team to solve. And if we're back 9 months earlier, we know that we can plan accordingly and plan our activities and our learning and our execution to hit that 9 months, versus kind of praying, for lack of better words, that it's all going to come together in a typical Gantt chart, in a typical traditional that, okay, we estimated everything, we think it's 9 months, and we're just going to pray it works. And we take the opposite risk profile approach, is that let's tackle the things that we know are going to drive the risk. We're going to identify those. At some point, we're going to have to do trade-offs. There's going to be much earlier. Do we need to add resources? We know, 1/3 through the project, we need to add resources in these 3 key areas, these 2 key areas. We need to outsource this. We need to think about scope differently. How are we going to optimize value? The tough decisions are asked much earlier, and that's what gives you that predictability and risk profile. So I like what you're saying, Reggie, that points and burn-ups going away, even for software. Okay, any questions? I just wanted to address that one thing. Any questions before we dive into a couple use cases real quick? All right, let's dive in, and then we'll still have hopefully a couple minutes to wrap around any questions. Just to give you, see if you can visualize this with a couple of companies and products. That this is an industrial process control company, kind of like an intelligent meter that you might find in a flowing for water, electric, gas, etc. The very sophisticated product manager would write requirements. They wrote 400 plus requirements. And this is a company that had long front ends, had very sophisticated R&D group. They wanted to get it right. They wanted to commit to the schedule. They wanted to commit to the solution. So they would take literally months. They were working through these requirements. 2 months later, they got through about 50 requirements. And that's when we started working with them and said, okay, well, something's got to change here. The front end is just way too long. And once we have a changing requirement, their change management process was extremely difficult and rigorous. So what they did is adopting MAD principles, agile principles, is start out with that strategic intent, not those 400 plus requirements, but an understanding of the framework of the solution, really a skeleton architecture in a lot of ways. It has some gaps. And then they break it into two. So requirements, we often ask teams to remove the word requirement from your vocabulary because requirements assumes that you know both the solution and the customer need, and you've already identified the optimal outcome. And we know that is baked on assumptions. So what we do is break it apart. The team starts with understanding customer outcomes. What are customers trying to accomplish? Who are we talking about? What's the priorities? All that. Then we think about what is the possible architecture, the possible major attributes. Where's the areas of challenge? And we bring those together in matrix thinking. That's kind of bringing that house of quality thinking together. And then they identify which of these attributes need the most attention for innovation, which are going to drive the most risk. And let's come up with a plan together collaboratively. Is it a technical problem? Is it a commercial problem? It's usually a combination where we're going to have to identify some options. We want to get some of this in front of customers quickly. We work together on what does that look like. So what they're really identifying is the path to success versus aligning on a piece of paper. That's the contract. So through rapid prototyping, rapid feedback loops, they're able to reduce that front end by 80%, aligning the team, and they were able to execute much faster because they had that focus, and ultimately 40% faster time to market with that one innovation solution. Similarly, a satellite communication encryption company, they also had long front ends, but for a little different reason. They had very integrated, elegant solutions. They always wanted to integrate and come up with, the perfect chipset, the perfect one board solution. And that was kind of just their modus operandi, that's how they worked, and they wanted elegance, and it makes sense, and they gave them these long development cycles. So working through the on-ramp, just taking another view of what's the real constraint here. And they started out by asking a simple question: how might we develop a prototype that we can trial with customers in 9 months? And that's one of the key principles that we build on, is to look forward, plan back. It doesn't mean look forward all the way to the end of the project. We're looking forward to that next major learning event, and then planning backwards a little bit to make sure that we have iterations and sprints that align to that across discipline. In this case, they wanted that prototype. And so they were able to rethink the whole architecture. Where they used to just kind of lay out this integrated approach, they said, what if we kept most of the circuitry, the capabilities from the existing one? We created a daughter board that we could add the new protocol with a different chipset on top of that and have it and integrate that. And they're able to do that. They got the prototype out there. Customers were absolutely happy with it because it did everything that it needed to do. Because at the end of the day, it had to do decryption and communication. They were able to trial it in 9 months. They actually launched it in 6 to 15 months. And then they could do a fast follower if they wanted to, but they could plan as part of their portfolio to do the more integrated approach, more sophisticated, but then they could also leverage the feedback from that first product out there from being early to market. So able to get higher margins being a first to market, and then they could even improve margins more with the next generation that was more integrated. So a lot of benefits just from rethinking your project from that front end. Last example is a robotics, obviously a big trend. This was a new office cleaning robot for industrial purpose. They had 18-month development cycles, and actually they were pretty happy with that, because we know if you add shorter cycles, you put more SKUs into the marketplace, you got more cost. You got to worry about parts more. You got to worry about supporting different product SKUs more, et cetera. So they were happy with their development cycles. What they weren't happy with was their margins. And so they wanted to figure out how Agile could help with their margin. So it doesn't mean we're always trying to get speed. It's just a tool, whatever we want to use it for. And one of their challenges was product management would write requirements, and they'd always add a lot more features than they knew R&D could deliver. And I used to do this as a product manager. You'd always overload R&D, thinking that I need this, knowing that you're going to get this. and you would even put them in P1, P2, P3, etc. So it often became a wish list, and we want to avoid that. We want a collaborative discussion, so they used Agile principles, MAHD framework to work through what are the real priorities for customers. Let's get those customer outcomes clarified. How do we get early customer feedback using the rapid prototypes to validate? And really came down to which features don't we want to deliver? How do we cut cost on the things that customers don't care about as much? And so they're able to do that and get their two levels. So margins are always come in two parts, higher price or lower cost. In this case, they're able to do both because they could get a product out there with more certainty. They were able to have less discounts because they were earlier to market with certain valuable features. So the price pressure was removed for discounting, and then the cost itself they were able to reduce because they were able to simplify in a lot of areas. They gave them lower cost. And we'll talk about Steve Jobs again a little bit as our conclusion, but he was the master of this. Is how do I take what was often a complex product that companies didn't know was creating value, so they'd add a lot of complexity and remove until you get down to the core of the value and optimizes margins and costs. And Apple's, of course, has amazing margins. Also help with predictable outcomes that once I know when I can deliver something, what time, I can plan for a launch. And that's a big benefit. I can have a much stronger high impact launch if I know what I'm going to deliver, when I'm going to deliver it. And we can do that more in a MAHD approach. So let me wrap up with this. Another Steve Jobs anecdote, because I know we're getting to the top of the hour. How do you take over a $10 billion industry? I used to be in this industry at the time, watching these products evolve, and Steve Jobs is the master of this. Where Apple almost failed, was near bankruptcy, and then Steve Jobs came back and launched the iPod MP3 player. And he was applying Agile principles from the beginning, where he would create rapid prototypes just with foam mock-ups. They would put lead weights into them, have executives, different people, put them in their pocket, walk around. Is this the right weight, the right form factor? Later, they would use later prototypes. They would sink them in water to see how much displacement was left, how much room was still left in the chassis to do further condensing of components, how much room to have inside to make it lighter and even smaller. So they were naturally used learning cycles, collaboration, these creative solutions. Competitors, Rio, if you're familiar with the industry, they were leaders in this market. They were founders in the market. They came out with a very similar product on a checklist basis. Even using some sprints and using kind of time boxing, but never really captured the Agile mindset. And Apple took over the market within months, and Rio was out of the market within 2 years. Officially, I think 3 years they left the market after this. So it does work, but you have to think about Agile for hardware as a market success process. If you do that, you adopt the rock polishing metaphors that Steve Jobs did. And you have the framework to do it. We know it works. You can go faster, get better solutions. If you want to learn more about this, and then we'll open up for questions, and we're here for a few minutes if anybody wants to stay with us. Visit mahdframework.com, download resources, and of course contact us if you want to learn more about learning options. But that's where we are. I know I had to kind of finish up quickly because I wanted to hit our time frame. Let's pause here. Any questions or thoughts?
Let me just say thank you while we give people a minute to gather their thoughts and questions here. But Dorian, Vishal, thank you very much. That was excellent.
Thank you. We appreciate the opportunity. We know Agile for hardware is new to a lot of people, and we love, sometimes we'll talk to folks, and I used to be an electrical engineer, I mentioned, and you have a way of doing things, and asking them to write everything they're doing in user stories now, you're not going to get acceptance from that. So we have to think about it differently for hardware folks. So every time that we use Agile dogma for hardware folks, you're likely going to get some pushback. But if you treat it in a way that helps them be successful, helps them use their skills a lot of ways. Electrical engineer, just tell me the problem. I'm going to help. I'm the expert. That's what I do. I'll help you find the ultimate solution. So don't give me the answer. Give me a great problem to solve. And that's what we're looking for.
And the user stories is interesting. I mean, we've had people like all the time, like, oh, Agile's all about your user stories and your epics and all that. And I always chuckle a little bit. I mean, go read the Scrum Guide. It just, all it says is product backlog item. You can do whatever format you want, right? Go figure out what works for you.
Exactly.
We get really held on to like user stories or Agile, but it's really kind of just funny. So, well, thank you very
Well, thank
much.
you. Yeah.
Any
Yeah.
questions?
A lot of it. Yeah. Yeah. We're here for a few minutes. Any questions?
Yeah, I've got a couple of comments. First of all, this is really great. Really enjoyed your presentation.
Thank you.
It speaks a lot. So that's kind of exciting to discover this. Yeah, I've worked in that Agile world for quite a number of years. Some purely software, and then some environments where we've got hardware involved. I think what summed it up for me, or says it to me, is the comment about the question you might ask at the end of a sprint: what do we need to learn next? I think for me that's huge. I know we kind of use that in lean, things like that, but I think because we're working with hardware, it's a little bit unpredictable. We're kind of like, well, we tried that, we understand that now. What should we learn next in this to get to the end result? So I find that sums it up very well. One of the questions I had that sort of accompanies that, though, at those, if you're kind of doing your typical sprint ceremonies or agile ceremonies, and you have your presentation, demo, prototype, whatever it is, you've got something working by the end of the sprint, and then you can demonstrate it, and then you get feedback on it and pivot as necessary. Do you find that hardware teams struggle, especially at the beginning, to show something that's working? One of the principles is you demonstrate something that actually works after your 2-week cycle or whatever.
Well, we don't require that, and we wouldn't ask them to do that because it's contrary to efficiency, and it depends on the project. So we want to let the needs of the project and of course the company dictate what happens in any given iteration. Because if it's a simple cost reduction, a simple incremental solution, do I need a rich prototype plan? Probably not. I can use 80% of stage gate thinking. I might do one rapid prototype to validate something, but I don't need a complex iteration, a prototyping strategy. So we want the needs of the project to dictate things like what is the prototype strategy, and that's what comes off the on-ramp. We want them to think about it deeply, give them the tools and the approach to think about it, and we wouldn't ask for a demonstration every sprint. The sprints in our world, these 2-week sprints, are heads down. The disciplines are heads down. Electrical engineering is doing their maybe a prototype of a PCB with some working firmware, and they collaborate across different pieces of different disciplines, different swim lanes. But the real working goal is towards these IPAC goals. And it's one of the things that came out in 2.0, where we launched this, we trialed it, and the question came out similar to what you're suggesting is what's the right set of milestones for an iteration? And it always came down to what's a reasonable prototype? And based on what we need to learn, that dictated a little bit about the level of prototype, the fidelity. In a lot of cases early on, it's simulation, it's paper, it's something, and then we demonstrate a brochure. That's our demonstration. And we put it in front of customers to get feedback, have them circle, is this important, is this not important, get some early direction. And then another iteration might be, you know what, they really didn't understand if this device needed a full color interface, or is black and white okay, or does it need any interface? So let's do a quick mock-up with a couple of options there, get it in front of customers. And so you're doing this rapid learning cycle, but you're letting the needs of the project dictate. And so these iterations are flexible. Could be 3 or 4 sprints. We don't like to see a iteration longer than 6 sprints. But for longer learning, a richer prototype, it's okay to go a little longer because we also have to track dependencies. We're tracking lead times that software doesn't have. So we want to look forward, plan for those, plan back. We call these major learning events and minor learning events. And so they're always looking forward to the next big one, planning back a little bit. Sometimes they'll do one sprint, one iteration that's one sprint in the middle, where they'll finish a prototype in one iteration. They'll get it into the field or in front of customers or whatever they need to do for learning. Then they'll take that learning and plan it for the next iteration. So we want the needs of the project and the team to dictate what happens within the within the sprints and within the iterations. That's how you get to speed. That's how you get the efficiency. It's one of the differences with SAFe, for example, is they often have 3-month kind of planning increments. And what often happens is the increment dictates the development. I mean, we want the development to dictate the increment. And so it's just a little bit of a reverse mentality that focuses on what do we need to learn, when do we need to learn it, how are we going to learn it, how fast can we learn it, and what does that look like for the next iteration. And if it's a huge iteration, we break that down into a couple of smaller iterations. I know that was a long answer, but did that explain why we don't even ask for people at sprints to do demonstrable output? We ask teams at the IPAC iteration level to do those demonstrations.
Yeah. No, that makes a lot of sense. What pops to mind is you could be using a sprint to prove or disprove a particular hypothesis you might have had, right?
Exactly.
Yep.
That's why the early sprints, early iterations are often sprint,
Yeah.
like these tight iterations. Exactly.
Yep.
Let's prove that question if we need. And it's not serial. A lot of people think, oh, Agile is serial problem solving. Let's solve one problem, then the team's going to solve another problem, then to solve another problem. We know that doesn't work, right? Things have to happen in parallel as much as possible. One prototype hopefully is looking at multiple rocks, not just one big rock. And so and a lot of it comes down to those constraints. If we have a 3-month project, we typically do in 9 months. We better be learning a lot of things in parallel. But the team knows that, and they can then create a plan to do that.
Cool. Thanks for the answers. Yeah, it's really good. Really good.
Thank you. Great questions.
Did
Can
you have
you
something,
hear me?
Jonathan?
Can you hear me?
Yes.
Yeah.
You can. Okay. I wasn't sure. I'm looking at your companies that have gone mad.
Yeah.
And I see Siemens and Philips. And I work in a kind of medical industry, and I know you have like FDA audits and whatnot, and you have to define processes and then prove that you're following the process.
Yeah.
That feels like there could be some difficulty here. Maybe.
Yeah.
But maybe
Yeah.
there's not. Maybe you've resolved that or are in the process of resolving that.
Yeah. There really is no conflict, because what we're saying, and let's bring to this picture, is that again, it comes back to the needs of the project. If you're doing, and we're actually coming out with a series of white papers on compliance in medical devices. If you need to do rigid compliance, you want to think about it right from the beginning in the on-ramp. One path might take you down a very different compliance path than another. You want to bring that up right up front. And then as you're working through it, you're really treating that compliance or certification, the company with the process control, that rigid certification process. Trying to bring up this one picture with Michelle, this one, is that you're thinking about all of that in parallel, and it's often a swim lane. It's like, okay, compliance, and then the team in IPAC iterations. If we know that risk is typically because of this, in compliance, and let's say you're building AI into your next device. And it's a huge difference if I have embedded AI that's doing local training, or I do, so cloud-based AI that is global training. Your compliance might be completely different, and you want to capture that, identify that risk early, and come up with a compliance strategy that mitigates that, so that when you're ready for submission, that final submission that you just can't avoid, that your risk went dramatically down versus up. There's no magic, of course, that's going to get your compliant, unless you pay for extra dollars, et cetera. But sometimes things are out of your hand, and so you're just trying to optimize for the things that you can control, and then you're planning for it in those IPAC iterations, not as rigidly as you might a stage gate, but in a lot of ways actually more, because the team's focused on it collaboratively and earlier and based on the learning cycles versus a checklist based. Does that make sense?
Yeah. And I think one thing I would add about compliance is, right, at the end of the day, the good thing about compliance is that you kind of know what you need to have at the end. The way if you think about this process, everything is meant to evolve, including your understanding of what the customer actually wants, what the real problem is, and then therefore what the solution might be. So the idea is that even the compliance aspect, the good thing is actually that's the most clear part, that hey, at the end we need to be able to show this, these are the documents we need to create. So the idea is the teams continually working through building those as they go, so that they can prove at the end that they followed what they had said they would, right? Compliance basically is that, right? Tell me what you're going to do and then show me that you actually did what you said. So
I think the big,
kind of
highly related is it's understanding the constraints right up front as a team. One of the big complaints, the skepticism is we can't go agile because we have to hit schedules. And so we can't do agile. But if you understand that constraint is just part of the problem for the team to solve, and you clarify that, and you set the constraint is, August, whatever it is, we got to hit this date. The team is very capable of working backwards and saying, if we're going to hit August, we got to get ready for manufacturing in April, which means we need to freeze design in March. Now it starts to feel a little bit Gantt charty, but it's not. It's just reality. And through the IPAC iteration planning, they always have in the entire schedule at a big picture laid out. They know those milestones because they know that constraint. And then the team is aligning and agreeing on the path to get to each of those milestones. There's a lot of fuzzy in the middle, just like there would be in a traditional project. But the core is they're assuming they don't know everything. In a Gantt chart or a traditional, we assume we know how it's going to unfold. And we're praying that what we said is going to hit 9 months hits 9 months. What we're saying in an agile environment is we understand the 9 month constraint. We're going to be very aggressive up front to make these difficult trade-off decisions. We might have to invest more heavily in a couple of prototypes to validate a key assumption. We're going to do that earlier, and we're going to even spend a few dollars more on it to get that clarity and remove that risk so that we can hit the 9 months. And we typically would never get that in traditional because the team's just kind of praying that it works, and they bring it all together, and then at the end they say, well, it didn't work. It took 3 board spins. We thought it would take 2. But we want to learn that much earlier if the constraint is the date. If the constraint is not the date, then we operate differently. Whether it's value, cost, or whatever the constraints are. But the key is to give that team that strategic intent and let the strength of the team work through it and develop a path to success. And they can do that typically.
Oh, one small thing on that I would add also is that, typically with software, especially agile software, there's this whole big idea of MVP. And in hardware, that doesn't make sense because you can't just have a baseline product and put it out there because it's going to survive, right? You can't just upgrade it. So the idea is that what we talk about is OVP, an optimal viable product. So it might have some bells and whistles as well, because you want to make sure that when it hits its market success, right? We want to build towards market success and not just build a product. With software, you can keep iterating. Hardware, once it's out there, it's harder to just
Gotta live with it.
in place.
Well, and I think the satellite product is our good example of an OVP. They agreed that let's not over design this thing. Let's not worry about elegance. Let's get it out there so it works. Customers are satisfied with it, and then we can work on the next generation. So yeah, some of it comes down to strategy. In a lot of cases, when companies are learning Agile for hardware, they have to rethink how they're approaching product strategy, market strategy, their roadmaps. That's why the complete MAHD framework is important. As you get good at projects, you're always going to trade off resources across projects. You're always going to be looking at prioritization across projects. So that requires more of a portfolio view as well. So it's hard to do Agile in isolation for long because what you decide at the portfolio level is going to have an impact at each project level. So ideally, you're taking an end-to-end product lifecycle Agile approach.